So if we step back and take a look at the state of the data warehouse today, how would you describe it has evolved? And what are some of the demands and challenges that it now faces? And Chad, let's get you to kick it off.
Sure, thanks, Stephanie. So given it's a high-level question, start really at the macro trends here. And storage and processing in recent years have become increasingly cheap. And you can now scale those resources using either the Google Cloud Platform or frankly any of the other ones as well. And this reduction in price allows you to save money just straight off the bat on on the spending on those resources, but it also allows cloud providers such as Google to scale their offerings. In particular, one of the aspects of Google's cloud is the interior network. We actually have a petabit network that allows different computers in our data centers to communicate with each other, and that allows for the massively parallel processing that gives BigQuery its actual speed and capability. And so those technical traits or those technical developments have really reshaped what enterprise data warehouses can do and should do. In previous years, enterprise data warehouses have grown up to be very reliable, but sometimes somewhat static beasts in that they require particular data models to be conformed to be developed so that specific questions can be asked of that data. With cloud and with Google BigQuery in particular, you don't need to generate indices, and so you can ask arbitrary questions of almost arbitrarily large data sets.
Yeah, and I would also add that there is, in the last few years, there is a huge expansion in terms of volume, variety, and velocity of data that organizations see. So it's not anymore about internal data, and organizations started to augment enterprise information with outside open source data, some social network. So it's not structured anymore, so there's quite a bit of unstructured data that flows into analytical solutions. And also there is a huge shift that we observe right now in terms of moving from batch-based system into streaming. So and for that, data warehouse have to be adapted and be capable of accepting events as they happened. Yeah, all those things, so increase in volume, variety, velocity, also there is a change in how organization approach analytics and reporting. If before there was a team of analysts trying to develop, analyze the requirement and trying to develop reports around those. Nowadays, we observe that more and more organizations, they give power to end users to ask whatever questions they might have. And so they have to provide the infrastructure capable of handling this unpredictable load and unpredictable concurrency. And that's where Google BigQuery comes to play very well.
Yeah, the word that we've come to be using around this is Agile, and you mentioned it just a second ago, Victor. Vladimir, apologies. In that you want to create a system that can handle the scope and scale of the data that's coming in, even when you're talking about integrating your own company's data with data from other sources, like perhaps the U.S. Census or NOAA weather data, et cetera. So you want a system that can handle those federated data sources, regardless of what they are, and then regardless of what the question is. And so, Agile Enterprise Data Warehouse is I think one of the things that the industry is going to be confronted to deliver, because that's what the data demands of customers are.
Well, and when it comes to Agile, I'm not sure about you, Chad, but what we started to observe as well is that if before organization was spending quite a bit of time trying to design dimensional model, they were trying to predict all possible questions that could come up and make a model that will fit all possible needs. Right now we see that many organizations start to be more flexible in this nature, and they're willing to experiment and iterate faster, so they would deploy data model that is sufficient for whatever question and requirements they might have right now, but at the same time push all information in a raw format in cheap storage, cloud storage specifically. And if the requirement change or there is an extra piece of information and data point that might be needed or aggregation or whatever, they can go back and they can quickly, with abundance of resources and by the minute billing, they can quickly start the processing, augment their existing information with some missing pieces. So it gives them freedom to experiment and iterate much faster than they used to.
Yeah, that's a great point, actually. And specifically when you talk about data models or normalized data models like star schema or snowflake schema versus a denormalized flattened model, we're seeing our customers. We actually held a customer conference not too long ago, and one customer was talking about how they had imported a fully normalized model into BigQuery. And we're talking about their experience with that. And another customer got up to speak just a few minutes later and said, hey, that's a great story that you just told, but you should really try denormalizing it because at our company we got a 10x increase in productivity out of our analysts and a 5x reduction in cost. And so when you're talking about flexible data models, I think companies would be really wise to look at a denormalized model.